Hello children, so here we are doing numericals of the chapter light, and especially we are in the chapter mirror. We have studied about the sign conventions and now we are going to tackle numericals, especially the ones in which the concept of the light chapter and the sign convention etc. is tested. So Kaushal sir, Sachin sir, first question on the computer screen which you will put over there. But before that, let us try to understand that when we are talking about mirror, two things should be very clear. First thing is that you should know the formula. Mirror formula is this: the relationship between focal length, image distance and object distance. Focal length is denoted by F, image distance by V and object distance by U. And secondly, the magnification in case of mirror is always taken as minus V by U. V is the image distance by object distance, and it is also height of the image by height of the object, etc. But two things, whenever you are dealing with mirror, these two figures should be in your mind. It should be imprinted. You can just look at it and then you can capture that as a screenshot in your mind. That concave mirror has got focal length behind, you say this way, concave mirror has focal length where you have to come back from the pole in the direction opposite to the incident ray. So focus of a concave mirror, focal length of a concave mirror is always negative. And if this diagram you see ray comes this way, goes reflected this way, then you extend and you get a virtual focus of what? Of convex mirror. So convex mirror will be having a focal length positive. This you have to understand. Now let us see what Sachin sir and Kaushal sir have put on the screen. The question, sir, please. The linear magnification produced by a spherical mirror is +3. Alright, then analyze this data and also tell the type of the mirror and the position of the object with respect to pole of the mirror and draw the ray diagram. Okay, very good. I am shaking a little bit. So magnification is +3. Magnification when is positive, remember magnification is positive. What does this mean? That whenever there is a positive magnification sign, that means the image is virtual and erect, and it is 3 by 1. You tell yourself if the denominator is not present, if it is in integral form, convert it into a fraction with denominator 1. In case if it is not in fraction, now you see numerator is greater than the denominator, so it is a magnified image. Alright, and if it was vice versa, then it was a diminished image. That means if the numerator was smaller, if the magnification comes 2 by 3 etc. like that, that means diminished image. Alright, so these two things you have to say. So first thing is magnification is +3. So they are asking what type of analyze this data and tell firstly what is the type of the mirror. So mirror magnified means you have to cancel out convex, because convex mirror always form diminished image. So the mirror is concave. First answer is mirror is concave. Secondly, position is, what is the position? Position, this type of the magnification means what is the position? The object is kept between pole and focus, and that is why you are getting the image beyond the or behind the mirror. Simple case is this one. Simple case is this one. This is the case. Always when you are drawing, please remember pole exactly after 2 cm focus and then center of curvature. Teachers will tell me why 2 cm, you can take 3 and 3. No problem, but then it becomes little unnecessary. It uses a lot of spacing a copy. So here is the case. This case is like this. The object is kept between focus and pole. So take out one ray parallel to the principal axis. Draw the diagram that the ray is going like this, and then it is coming back to focus. Another one is coming out in such a way, that it is going through C. That means it comes out and it goes through C. Then let us see and use your scale. Alright, and then you extend. These two rays will not meet this side, so that means extend with dotted line. Use the scale. I am not using the scale, but use the scale. this line should be a straight line, this whole thing should be a straight line. And then what we are getting? We are getting the object which is magnified and erect and 3 times the size. Alright, this should, and the image is virtual. So these two things are there. So the first question more or less is solved. Now let us go to the second question. Sir, please, second question. So list least 2 possible ways when a concave mirror forms a magnified image. Alright, magnified image, and state the difference. So first case is this. Case 1 already. For question number 2, the same diagram can be used. First case is when the object is kept between pole and focus, then the image is magnified. Alright, and it is erect, it is virtual. And in the second case, the object is kept between focus and center of curvature in concave mirror. When you are having magnified image, you have to totally cancel out the presence of convex mirror. Convex mirror never forms magnified image. So we are taking concave mirror, and here is the case. The object is kept between focus and center of curvature. So what is happening? A ray comes, it is parallel and it goes this way. Another ray originates from, another ray originates from the object and tip of the object, but it is in line with the center of curvature. So here we get the magnified image. So, but there is a difference between these two images. This image is real inverted, therefore the magnification will come negative in this case and the magnification will come positive in this case, and in both the case numerator will be larger than the denominator if you are taking numerical value and you are doing calculations. So once more, 2 possible ways where image is magnified in case of a concave mirror. One is the object is kept between focus and pole and the image will be virtual erect. Alright, and second is when the object is kept between center of curvature and focus, or focus and center of curvature, but the image will be real and inverted. So this is the second question done. Now let us go to the third question. What is the third question? Let us see. So the third question on your computer screen, let us put it here. The image formed by a spherical mirror is real inverted and its magnification is -2. The image formed by a spherical mirror is real inverted and its magnification is -2. If they would not have even given, real and inverted, just magnification, if they would have given -2, still -2 by 1 means what? First thing is negative sign means the image is inverted and it is real, and second 2 by 1, that means numerator is greater than the denominator, then the image is magnified. So the magnification is given -2 for this case, so -2 by 1. Even if they would not have mentioned anything, just given magnification -2, that means the image is magnified, not diminished, because numerator is greater over here, the value. Alright, so it is so this again cancel out, convex mirror gets cancelled out, and therefore we are getting this mirror as a concave mirror, Alright, then they are telling if the image distance is 30 centimeter from the mirror. So since it is negative, we have to understand the object is placed between focus and center of curvature. Therefore the image will be formed on the same side as of the object. So if we take u negative, then here v will be also negative 30, isn't it? Because what is this case? This case is when the object is kept between focus and center of curvature. So the image will be beyond c and on the same side. So that means from the pole, if you have to measure the image distance, we have to again come back. So you have to visualize that diagram. So v is -30. So we can get the object distance over here also. So what is the object distance? So we can write -v by -u. -v by u is equal to -2 with this formula. Alright, because the formula for magnification is -v by u. Now this cancelled out. U is equal to v by 2. We place -30 by 2. So u is equal to minus 15 centimeter. We can get the focal length. Are they telling us to find out the focal length? Yes, find out the focal length. So 1 by f is equal to 1 by v plus 1 by u. Please let us see. 1 by f is equal to, what will happen? Negative 1 by 30. 1 by u is negative 15. So here it will be 15. So 1 by f is equal to 30 minus 1 minus 2. This implies that 1 by f will be equal to minus 3 by 30. So this implies f will be equal to 30 by minus 3. So minus 10 centimeter. So we are getting the value of focal length as minus 10 centimeter. Now they are telling, let us see what they are telling. Now they are telling that what will happen if the image, list two characteristic of the image, list two characteristic of the image form if the object is moved 10 centimeter towards the mirror. So now let us try to make the diagram. What was the actual case just now? In this case, what had happened? So this is the pole, this is the focus, this is the center of curvature. This is the focal length was 10. Okay, center of curvature will be 20. The object was kept at 15 and the image was on this side, isn't it? 30. But now 15, from 15, say for example, object is here, it is moved 10 centimeter. So that means from here to here is 15, 10 centimeter it goes. So now the object, new object distance is minus 5. New object distance is minus 5. Focal length remains minus 10 centimeter. We can easily calculate the image distance. Image should come positive, isn't it? Because now what is the case? It is between focus and pole. So let us try to find out. Now new case. Now I will change the color of the ink so that now what are we doing? We are doing the last part of the question. What is written? List two characteristic of the image form when the object is moved 10 centimeter towards the mirror. That means now when you move it 10 centimeter, it is between focus and pole. Obviously the image will be virtual and erect and magnified, but let us find it out. We will find it out. 1 by v, now from here we can get the formula. 1 by v is equal to 1 by f minus 1 by u. So 1 by v in new circumstances, negative 10, focal length is negative 10 minus 1 by u, u will be negative 5. So this changes. So now 1 by v is equal to 10 is the LCM, negative 1, 2. So 1 by v is equal to 1 by 10. So v will be 10 centimeter. Alright, and positive. That means the image will be behind the mirror. That means opposite side of the object. Now here we can again calculate the magnification. Magnification is minus v by u. So minus v. V is plus 10. This is the sign of negative sign is of the formula, and u is minus 5. So that means the image is 2 times magnified. The image is 2 times magnified. It is virtual and it is erect. Thanks a lot.